And welcome to Climate Chat. I'm your host, Dan Miller. And today we are going to be talking about why SRM, or better known as solar radiation management or sunlight reflection methods, also known as solar geoengineering, why that is required. And to be clear, by required, I mean we must do it or otherwise we will suffer unacceptable consequences. And we'll talk all about that. We're going to just jump right into it. So again, why SRM or solar geoengineering is required. And first of all, let's talk about what is solar geoengineering. Well, SRM or solar geoengineering is reflecting a small amount of sunlight back into space, about 1 or 2%, in order to cool the Earth. And as I mentioned, it has different names: solar geoengineering or SRM. I'm going to be using SRM a lot in this presentation because it's easier and faster to say. There's multiple types of ways to reflect the sun away. You could put mirrors on the ground, although you'd need a lot of them. You can try to enhance clouds, create clouds, make clouds brighter, and that will reflect the sun. If you do it over the ocean, it's called marine cloud brightening. You can also put particles, such as sulfur particles, in the stratosphere, and that will also reflect the sun. That's called stratospheric aerosol injection, or SAI. It's the main form of SRM we're going to be talking about today. But you could also put a very large sunshade in space between the sun and the Earth, and that would also block a small amount of sunlight as well. All of these things are possible. Some are easier and faster to do, and in the case of stratospheric aerosol injection, we know it will work, and because it's, as you're about to see, it mimics what large volcanoes do. So how do we know it will work? Well, as I just mentioned, very large volcanoes, not the normal volcanoes, but really large ones, put megatons of sulfur into the stratosphere, and they cool the Earth for a year or two. And the last time this happened was 1991, when Mount Pinatubo erupted, and it cooled the Earth by about half a degree or so for a year or so. And another reason we know it works is because we're doing it today on a massive scale. Now, we're not doing it for the purpose of cooling the Earth, but that's its effect anyway. We are emitting about 70 million tons of sulfur dioxide into the lower atmosphere, the troposphere, and we're doing that because of coal plants, ships, industrial plants of all kinds. So when you burn fossil fuels, one of the side effects is it releases sulfur dioxide, and that does a good job not only of reflecting the sun, but it also helps create clouds and make them brighter, and therefore that also cools. And so this whole process is cooling the Earth by about half a degree Celsius to 1 degree Celsius, and perhaps even more, and that's happening today. So if we cleaned up all that pollution tomorrow, the temperature would immediately jump up by half to 1 or maybe more degrees Celsius. And we are cleaning up this pollution slowly and sometimes more quickly than others, and that's is causing accelerated warming. And we've talked a lot about that on this program and in other programs. So how would you implement SRM? Well, if we're going to be putting sulfur dioxide into the stratosphere, we would need sort of cargo planes that can fly up to the stratosphere. Currently, we don't really have those because, to be honest with you, we never needed them. But we could do it. You'd need larger wings and more engines. So instead of a 2-engine plane, you might have a 4 or 6-engine plane with large wings that could get up into the stratosphere. There are planes today that can fly there, but they tend to be smaller. And we would have to release on the order, I mean, not a specific number, but on the order of about 5 million tons of sulfur dioxide each year. And that's, again, way less than what we're putting up there today in the lower atmosphere, which is about 70 million tons, and was as high as about 100 million tons. The whole process would be relatively inexpensive, $5 billion a year. Sounds like a lot of money, but actually most other solutions are measured in trillions of dollars rather than billions of dollars. For example, removing CO2 from the atmosphere is a process that would cost trillions of dollars a year. And the good news about putting it in the stratosphere, it lasts about a year before it falls out. Unlike in the lower atmosphere, it only lasts a week. And that's why, by the way, you need so much less of it in the stratosphere. But when it falls out mostly as rain, and two-thirds of it falls out over the ocean because two-thirds of the Earth is ocean. So it's much safer for human health. The other way we do it today contributes to the deaths of about 8 million people a year through pollution, breathing in the pollution from the burning of fossil fuels. Why should we do it? Why are we required to do SRM in the near future? Well, we're at 1.5 degrees Celsius of warming right now. People argue with that a little bit, but we're there now. And we are on our way to 2 degrees in the 2030s and perhaps 3 degrees in the 2050s. There are climate scientists that might disagree with that. But the point is that it's such a dangerous situation that we have to assume it's going to happen. You know, when you're faced with something like that, when you're playing Russian roulette, you should assume you're going to get the bullet in the chamber, even if it's only 1 out of 6. Now, we're going to hit 3 degrees anyway. It might not be as early as the 2050s, but it's still on its way. And so therefore, again, we have to act. Now, what is 3 degrees? 3 degrees guarantees irreversible tipping points and may lead to the collapse of civilization. And it's not going to stop at 3 degrees unless we, dramatically cut our emissions, which we're not doing. So 3, 4 degrees, not compatible with organized global community, as has been said before. And how do we know we're not cutting our emissions rapidly? Well, they're at an all-time high right now. So we haven't even started lowering them yet. There is hope because of the growth of renewables that they'll start leveling off and then maybe even dropping a little bit. But that's actually not good enough. They have to be dropping like a rock right now, and they're not. And there's no plans to make that happen. And there is, I mentioned just earlier, there's no chance we're going to eliminate our emissions like very soon. And that's what would be required to avoid 2 and 3 degrees. Now, we can do emissions reduction, even though we're not, but we can start doing that. And we can also start removing carbon from the atmosphere, called carbon dioxide removal, or CDR. But those both act very slowly. Even if we implemented them both today, we wouldn't even notice much of an effect for many decades to come. However, solar radiation management, on the other hand, it acts almost immediately. You do it now, and in a few months, you notice it's getting cooler. And why do we need to do it? Well, the harm and suffering to both humans, to animals, to ecosystems, just from 1.5 degrees is substantial. It's here now, and it's going to accelerate in the coming years as we get up to 2, as we get up to 3 degrees of warming. And again, in these timeframes of the next few decades, only SRM can relieve the suffering that's going to occur. Even if we started emissions reduction and carbon removal, it wouldn't have any effect on the suffering that's going to happen over the next several decades. Another thing is sea level rise is based on cumulative warming. As we warm the ocean, it melts Antarctica, for example. And so if we just wait till the future, hey, we're gonna lower our emissions in the future, and then hopefully things will be okay, which they won't. But if you hope that, the other problem you're going to have is accelerated sea level rise, where if you do cool the Earth now, it will slow down that process, but not stop it. The other big thing that people don't realize is that warming leads to release of more greenhouse gases, which leads to more warming. And the opposite is also true. Cooling leads to less emissions of greenhouse gases and therefore more cooling. And therefore, SRM will actually lower emissions. And this can be seen in this chart that shows what happened after Mount Pinatubo erupted. The greenhouse gases, this is the famous Keeling curve, were growing at this rate, at a steady rate. And then when the volcano erupted, atmospheric CO2 lowered by roughly 4 parts per million, and then continued on a steady path that was essentially a new path with a slightly less emissions, because that was it was starting from a lower point. And it's a whole interesting talk on why that is, but that's not for today. So there are issues and problems that need to be addressed with SRM, including we need a lot more research before we can begin this. There hasn't been there's been a lot, but not enough. We have to learn more about how, when, and where to do it, and also how much SO2 to release. And then, of course, the engineering of the planes, which is pretty straightforward, but there still has to be done, and those kinds of things. There are concerns that putting sulfur dioxide in the stratosphere affects the ozone layer. It does a little bit. I've read that it would delay the repair of the ozone hole by about a couple of years. So it is some impact, but small. And there was a study that traded off the increased cancer deaths from the ozone hole versus the heat deaths from the extra warming. And it was greatly in favor of doing SRM in order to, it saved hundreds of thousands of lives a year by doing this, even accounting for slightly increased cancer deaths from ozone hole. If SRM is implemented, we still have to eliminate emissions and remove CO2 from the atmosphere, because people will tell you, hey, I'm worried about what's called termination shock. You cool the atmosphere, you keep doing it, and for some reason you stop. And just like cooling happens right away, if you stop, the warming would happen very quickly, and you would get back to where you would have been. Actually, less than you would have been, because we just talked about how cooling reduces emissions. So you would be less than what you would have been, but still it would be a lot and would be all of a sudden, and therefore traumatic. However, if you don't do SRM, of course, you're still going to have those temperatures. You're going to have them for sure, actually. You'd be guaranteed to have those temperatures, and actually slightly higher temperatures. Even though this is a risk, it's one that we can address by actually eliminating emissions and removing CO2 from the atmosphere over time. Now, there are three major objections to doing SRM that people talk about. One is the moral hazard. They say that if we have this cooling solution and you implement it and things cool off and things get better, well, that's going to reduce interest in eliminating fossil fuels, and we have to eliminate fossil fuels. Well, first of all, this assumes that we're not going to take climate change. We're going to continue to not take climate action seriously, and we're not going to have policies that, along with implementing SRM, also implement phase out of fossil fuels. That's what we need to be doing. And so if you claim that we're not going to take climate change seriously, well, then I would argue then if we choose to fail, then we will. But we could choose to succeed, and that would include eliminating emissions. And also, SRM isn't a reason to not lower emissions. As we're talking about here, it requires that you lower emissions so you avoid termination shock. So really, it's just being used as an excuse. It's not really a real reason for not lowering emissions. And it's a little bit like talking about, well, let's ban cancer treatments to encourage people to stop smoking. That's what this moral hazard argument is all about. The other big complaint or concern about SRM is the lack of fair, just, and effective international governance structure that could manage the deployment, decide, when and where and how to do it. Well, first of all, this is true. There isn't such a governance structure in place. A lot of people working on things, but it's not there. But the same is true for emissions reduction and fighting climate change. We have the COP process, the UN, but it's not an effective way to address the problem. So we deal with that, and that's causing the problem. But if we don't do SRM, then there'll be the mass suffering that we talked about. And if the temperatures keep climbing, then we will reach the point where civilization won't be able to continue, and therefore there won't be any international or national governance of any kind. So that's a totally unacceptable situation. So preventing doing this because you don't have governance structure in place doesn't really make sense. The answer is we have to address that issue and figure out how to do the governance. In other words, you don't wait for the governance to start planning and building, but you work on doing that simultaneously. And then one of the biggest objections is that people are concerned that there will be negative side effects of doing SRM. And there were negative side effects from Mount Pinatubo. Certain areas cooled off, rainfall patterns changed a bit for that year, and things like that. But we're still here, so we know it's not catastrophic. And SRM will probably have negative side effects like that. but we also know that they're going to be much, much less than the side effects of not implementing SRM, of dealing with 2 and 3 degrees of warming. And since, as we said, it mimics large volcanoes, we have a general idea of what the impacts will be. And of course, a volcano could go off when it's a normal temperature and get you colder than you should be. And that could be bad. But in this case, we wouldn't go down below where we should be. So that kind of thing won't happen. So in general, we know the impact side effects of SRM will be far, far less than the impacts of not doing SRM. And a little bit, this discussion, when people bring up the side effects, all they do is talk only about the side effects of SRM. They don't talk about the side effects of climate change. And that's a bit like talking about the chemotherapy and telling how terrible it is without ever mentioning, oh, by the way, you're using it to help cure cancer. And that's really the situation here. So in summary, what's going on here? Well, at this point, using SRM is the only assured way to avoid 2 to 3 degrees or more of warming. That level of warming is catastrophic and can lead to the collapse of civilization. Not saying it's guaranteed that it will, but it's too high a risk to accept. We know that SRMs mimic large volcanoes when done in the SAI way, but there's other ways to do it too. But that way we know mimics large volcanoes. So we know it works, and we know it's relatively safe. And when you do SRM, you have to do it in conjunction with phasing out fossil fuels and removing excess CO2 from the atmosphere, so that over time the termination shock issue goes away. And then you can actually stop doing the SRM once you get the atmosphere back to reasonable levels. So that's a bit on this. I hope you enjoyed this brief talk on a very important and actually complex subject, a lot of details to go into at other times. But if you like this program and you thought this content was useful, please like and subscribe, because we're here to inform people about climate change, and we want more people to see this kind of programming. So please help us out there. Leave a comment, like, subscribe, and hit the notification bell. Anyway, thank you very much. And thanks for listening to Climate Chat. And we're back. So, Stacy.
Hi.
Let me say something.
What's that?
Let me say something, Stacy, first.
Okay.
Happy birthday.
Thank you. Yes, another trip around the sun has happened.
Around the sun.
Yeah.
So, anyway.
And this year it's actually on my birthday. Usually it's like, I remember my best present that you got me was, what is that, 2 years ago now, was Jim Hansen. I think he was 2 days before my birthday, the first time we had him on, and I was all excited.
He just published a little communication saying that he expects 2027 to be 1.7 degrees of warming, and that's higher than what most people. Zeke Hosfather, who we've had on the program, just published something yesterday that says he thinks it's going to be 1.6. So we'll see.
In what year?
2027. So 2026 is expected to be a little less than the last few years, because, or comparable, because there's a La Nina, a cooling La Nina occurring now and fading away, and it's supposed to turn into an El Nino. But what happens is the impact, the temperature impact of those things happens, most of it happens in the following year. So you have the La Nina this year, then next year will be a little cooler. You have a El Nino in 2026. Its biggest impact will be in 2027. So anyway, so we'll see what happens there. But we should keep focused here today on SRM, and I have not been checking out the comments or anything like that, but you might have some questions of your own, and then Eli, and then we'll go to the YouTube questions as well.
Yeah, well, the one question is, and it's actually almost an Eli question, or for both of you, is the the feasibility of the physical system, the, space mirror thing.
Space-based mirror. Well, for
Yeah,
that, we should invite Eli on to give the answer to that question. Hey, Eli,
yeah.
are you there? Maybe you're not here
Yeah,
yet.
can you hear me all right?
Yeah, can hear you. So the question is, how feasible is the doing SRM using a space-based system?
So it's actually quite surprisingly feasible once we have the launch capacity that SpaceX looks to be working out with the Starship. When you actually calculate the fuel costs and the to launch something not just into orbit but to Lagrange point one, which is kind of like the best place to do this because you get a stable orbit between the Earth and the Sun. And while you're hanging out there, you can even open and close the wind shade, so to speak, so you have rapid dynamic control. So when we are able to launch things efficiently, this actually turns out quite surprisingly to be considerably less expensive than the much more studied stratospheric aerosol injection. The only thing that comes out cheaper is marine cloud brightening, which is also something that we really, really should do. And Australia is already experimenting with to save their coral reefs because they understand that once we lose things like coral reefs, they don't come back quickly at all. And I'll just quickly do a tangent on coral reefs. We are on track to lose something like 90% of coral reefs if we don't do anything, and that coral reefs support 40% of the animal life in the ocean. And just that in itself is a catastrophe that everybody should be really concerned about if they care about nature. What we don't really understand very well is what are the consequences for overall ocean ecology, and could that interfere with the way the ocean provides us with oxygen and the way it doesn't emit methane. Right, that's one situation we could find ourselves in with unmitigated climate change. But back to the space-based SRM. So one of the common objections is, well, what about all of the carbon that's going to be emitted to launch it? Actually, that comes up to under a quarter of a gigaton if we do it to the full scale of counterbalancing everything we've emitted since the Industrial Revolution. So that is a bargain, right? And by the way, you don't really have to use methalox or methane and liquid oxygen the way the Starship does. You can use hydrogen instead, and then you have no direct emissions associated with it. So it's very counterintuitive. Certainly, like the economics of launching things into space when this was first seriously analyzed in the late 80s, it just would have been prohibitive. But things have changed a lot, and this is much more viable than people realized. Will it happen quickly enough? I don't think we could ramp up quite quickly enough. We almost certainly will need something like stratospheric aerosol injection, along with other things like albedo modification, which we can do in other ways, like just greenhouses. They reflect a little bit of the light, and that has been shown in places in China to actually lower local temperatures, in addition to all of the benefits to growing crops more efficiently and being drought resistant and all the rest. So there are lots of things that we can do at several levels, but space-based SRM really is something that demands a lot more attention, is much more feasible, and you avoid all of the interaction with atmospheric chemistry that you would have with stratospheric aerosols. So it can't happen fast enough and big enough.
And roughly speaking, how big does the sunshade have to be to be effective in this application?
So
roughly
so
speaking?
we are talking about millions of square kilometers, and just if you think about the geometries involved, the goal to counterbalance the radiative forcing due to all of the greenhouse gases we've emitted, we have to cut down about 1.33% of the energy coming in from the sun. So if you imagine a disk that's the same radius as the Earth, between the Earth and the sun, you would want that disk, 1.3% filled, and very thin aluminum foil. We already know how to make it. It's more than we make for the all of the metallized potato chips bags, but we can do that at large scale.
Okay. All right. Anyway, that's good. Let's move on to the other issues. Stacey, did you
Yeah,
have another question? Or-
well, there are a couple like related or comments that have popped up. Well, I want to thank everyone for being here. And old Jack Wolf noted that we should employ bots like the fossil fuel industry does, because there are only 33 people watching when it should be 33,000 to start changing things. So with that, please like and subscribe and pass this along to your friends, coworkers, I don't care, enemies. Like, get people to watch so that they can hear this information, because there's a lot of um, head in the sand or denial, and time is not on our side.
Well,
So
also let me say that we're going to publish the talk I gave, not this part of it, as a separate video that's like 15 minutes long, maybe a few minutes more. And so that one might be more digestible for people, and therefore you can also promote that one when we publish it, maybe later today or tomorrow. And yeah, so hopefully we can start spreading the word, and we're going to try different formats, like doing shorter shows at times to make that happen.
So one thing that Nadia was talking about is about the effects on polar nights. Are space SRM methods powerful enough to induce indefinite polar nights? I'm not sure about that, but the one thing I love about it is, while the SAI, stratospheric aerosol injection, is we put it up there and then we have to kind of live with it for about a year. The space-based SRM, we have a switch, right, Eli? We can turn it kind of on, off,
Exactly.
a dimmer, switch or something.
Well, a year is also pretty good. I mean, like not doing it. First of all, you start off small. You're not going to do it like full blast the first time you use it. But you're going to try to knock off half a 0.05 degrees or 0.1 degrees off of the temperature. See how things are going, and then keep increasing it over time. And then if you don't like what you're doing, you can always turn that off too. So that's pretty good. Unlike, by the way, putting CO2 in the atmosphere. If you don't like it, you got to wait thousands of years, to
Right.
see what it would have been like to not do it. So
Yeah, the only difference is that if there were an actual big volcanic eruption, and we're doing full scale stratospheric aerosol injection, and it does take 6 months, everybody blames the people doing the SRM for the famine, right? There have been famines due to volcanic eruptions historically. Would that be worse than unmitigated climate change? Probably not, even factoring that in, because there are going to be famines due to climate change if we don't do anything, right? But dynamic control is always a good thing.
okay, so I see a question here that we can cover. Why not do low latitude albedo enhancement more massively done in built up areas and highly populated zones? This is things like you could put mirrors on the ground, but simply you could paint roofs white or paint roadways white, for example. These are things that would help reduce what's called the urban heat island effect, because you have so much paved and black surfaces in cities. They get hotter than the surrounding rural areas. So first of all, you can do that totally, and that's just in addition to doing SRM, because that helps more locally. It doesn't reduce the global temperature. It doesn't prevent tipping points. It doesn't, stop extreme weather. But what it does do is it helps in the local area. It cools local areas, so it makes those cities more habitable. So it's very good. But again, it's something that's really in addition to rather than instead of SRM.
One comment that was made is anything except reduction of emissions. F around and find out what could go wrong. And I say it because it bears repeating. So Dan mentioned it in his presentation as one of the issues that people have problems with is that, well, it'll give people an excuse. And I was one of those people nearly 5 years ago, actually still like probably 3.5 years ago. It took me a while to come around because I was like, this just gives us license to keep doing the things we're always doing. And Eli and Dan rightly were explaining to me, we need to do that anyway. This isn't a get out of jail free card because we have to keep doing it forever. And that is unsafe. And if we don't do it, or if we use that as an excuse, we're just assuming that we won't reduce emissions and everything's going to be so much worse. I don't know if that made sense, but all I'm saying is we absolutely must do both. This isn't an excuse to not get emissions to zero, to make the changes that we need to make. It just gives us more time so that we don't suffer the worst effects of what we hath wrought,
Well,
by
another way of looking at
littering.
it, I mean, you could really argue that it's actually a moral hazard in the opposite direction. Because right now, as everyone knows, I think most people know, that the impacts of climate change are felt first and worst by folks who don't have as many resources as those in the developing world. So the global South is suffering today
Yeah.
from changes in rainfall and agriculture, crazy heat waves and things like that. They're having those now, and they're going to only get worse as we get to 2 degrees and beyond. So what this argument is to say we want to keep those people suffering, because if you relieve their suffering and everybody else's, but if you relieve their suffering and everyone else's, the rich won't have as much reason to reduce fossil fuel emissions. So what you want to do is have the global South suffer to give more reasons for the wealthy to do what they should do anyway. And that something sounds wrong about that to me. I don't know. It's like if you can, and also of course there's more to it than that. If you wait for this to happen, for them to finally lower their emissions, and so you don't do this in the meantime, you're really getting closer and closer to the tipping point, such as AMOC collapse, West Antarctic ice sheet collapsing, which is probably going to happen anyway, and other tipping points, which are all one way, irreversible. Doesn't matter that you finally cut your emissions later, it won't matter. And so allowing the world to get to that point is also, to me, it sounds like a moral problem as well.
Well, yeah, I mean, it's the question is not, do we or do we not do SRM? In practical terms, the question is, do we do SRM in a smart way as soon as possible, or do we put, the whole world through a lot of misery to wind up, even when we start doing, if we've crossed over some tipping points, then the end point is worse than if we just did things earlier and smarter. Right now, the calculated risk for based on where people live, for anybody to experience one lethal wet bulb event per decade has about 250 million people currently at risk. Well, at 1.5, if we're at 1.5, right? When you get to 2 degrees, and that's where we're headed. Nobody thinks that we're going to thinks we're going to avoid that. Absent very drastic action, which is not, doesn't look like it's unfolding. Then you get to 1 billion people at risk of one or more lethal wet bulb events per decade. And as the temperature goes up, that number gets even larger. At some point, some government that's lost say, we're not going to do this. Our people will not let us stay in power if we don't do something that is a lethal, we're going to do something, right? That's if the world tries to not do research and say we're never going to do. At some point, things will get bad enough that somebody's going to do it. That's the right way to do this, is to be deliberate, figure out the most effective ways, collaborate as much as possible, but also not let anybody obstruct saving the only home we presently have for the sustainable civilization.
So I want to put this up here. Question: why would we try to do space SRM if we can't even do Earth SRM? Well, first of all, we are doing Earth SRM right now, today, on a massive scale. So we're putting in 10 times more sulfur dioxide into the atmosphere than we need if we do it in the correct, efficient way, which is to put that sulfur at a higher altitude into the stratosphere rather than dumping it near the surface atmosphere, near the lower part of the atmosphere. When we do it there, the pollution people breathe in, it contributes to the death of 8 million people a year. So it's not a good way to do it, but we are doing it, and we're doing 10 times more of it than we actually need to do to cool the Earth properly. And by the way, this accidental way we're doing it is cooling the Earth a lot. If that pollution all went away tomorrow, in a few months, the Earth would be at over 2 degrees of warming, maybe 2.5 degrees of warming, maybe even a little bit more. So it is being done today. It's effective. It's a very poor choice of the way to do it. It's inefficient, and it has serious health impacts on people. But doing it the right way means you can reduce the amount of stuff you put up in the atmosphere by a factor of 10 or more. I mean, so 95% reduction in the amount of stuff you put up there, and you put it in a place where people don't breathe it. And when it falls out as rain, not as particles in the atmosphere. So we breathe in very, very little of it. And most of it, by the way, would fall into the oceans rather than on land where people are. So there's a lot of reasons why it can be done. By the way, this certainly can be done. It's just the question, we just haven't chosen to do it yet. So that's, I think, the real answer to that. Okay.
So Nadia clarified her question about the induced polar night. It meaning she wants to be like what today is on the North Pole anyway, total darkness at both, or ideally both poles, for years on end as part of an emergency cool-off strategy to save the ice caps. Can you do that, Eli, with your space mirrors?
Okay, well, could you? Yes. Should you? No. We do not need to do anything nearly that drastic. I mean, if you wanted to focus on the poles, and I haven't analyze this in depth, but my semi-educated guess is that just doing something like extending the polar night by a month means that when you get to the following summer, there's still a lot more sea ice and the corresponding albedo, that you're getting more than just the direct effect of the SRM. You're getting the preserved albedo. I mean, right now we are getting less albedo than we did in the past from the poles because we've melted a lot of sea ice, right? Now, just by modestly doing SRM, we can stretch out what we do get to be more like it used to be before we screwed up the climate system, right? And stuff like that is not going to have dire ecological consequences or anything. And also, as Dan said, it won't be, just going from 0 to 100% right away. We will do things, we will scale things up, and we will learn along the way. And I think questions like this will be much better informed as we start doing it.
So here's a question about tipping points. If tipping points have actually already been reached in any subsystem of the global climate system, you can SRM all you want and will not help. For example, the hydrological cycle. Well, I'm not really sure about the hydrological cycle. I don't know what tipping point is referring to there, but it is true that if you pass a tipping point, then SRM is not necessarily going to help it, but it can help prevent tipping points. For example, we did a whole program on how SRM could actually strengthen the AMOC rather than what's happening now, where it's weakening. And one reason for that simply is it would, help refreeze Greenland and the Arctic by cooling them, and therefore means less fresh water flowing into the North Atlantic. The fresh water flowing into the North Atlantic is what is weakening the AMOC. Now, if we let the AMOC collapse, the AMOC partially feeds on itself. So once you let it collapse, then it does collapse even with SRM. So if we let it go that far, well, then we're kind of screwed. So while we can wait too long to do SRM, but if we do it quickly, it could actually help prevent some of these tipping points from happening. Doesn't mean all tipping points. I mean, ocean sea level rise is going to occur anyway. Doing SRM can slow that down, but it's not going to stop it. And so I'm not claiming SRM is a solution to all that ails us or something like that, or all climate issues.
I would like to stress that it is true that some tipping points are absolute hard, irreversible, but in a number of the definitions of the tipping points, there is the assumption that, well, we have this gradual process that it's an amplifying feedback, and there is a point at which we get committed to more and more of that. We do after we're committed to it doesn't change. But in the definition of committed to it and what we do, SRM has been taken off the table. Right? If SRM is on the table, where the tipping point actually is changes for many of them. Not for, the AMOC, as Dan mentioned, that is, we do know in geological history it has restarted, but restarting it is a different proposition than just like not having it slow down too much or shut off.
Okay.
One thing so going south, has is here all the time, and I think he lives in Greenland, so he has a lot to say about it. He's frustrated. He doesn't want SRM of any kind, and says, this one I liked it. Police should just confiscate cars from garages. I love it. It will never happen, but I love it. And it reminded me of the similarity. The fear of SRM is like the fear of autonomous vehicles. It's the new thing, and people don't want it, and they don't know anything about it, and they just think it's awful. Meanwhile, they turn a blind eye to the madness that's going on. So or stratospheric aerosol injection, putting sulfur up into the atmosphere, we do it every day. But because it's by accident, and it's fine that we kill all those people, just like human driving is killing, I think it's 1.3 million people globally a year, over 40,000 in the US every year. We just tolerate it, like, oh, that's the cost of doing business, instead of, here's this thing that could fix it. I'm not talking all of them. Waymo is the one that is has proven itself to be a solution. But I really wish people would open their eyes and look at the bigger picture and stop turning a blind eye to the thing that we have been accepting, the bad thing we've been accepting forever. And look
Actually,
at
I
the
think it's
thing
more
that could resolve it.
amazing that the burning of fossil fuels, just the pollution, not climate change, just the particulate pollution from burning fossil fuels kills 8 million people a year. It's 1 in 5 deaths on Earth, and no one talks about it. It's not even a subject that I bet 99% of people never even heard that fact. It's published in Harvard Medical School Journal. So that's beyond anything, any other problem anyone ever worries about, and there's no talk whatsoever. Inconvenient.
Well,
That's really an inconvenient truth, I guess.
in fairness, there is an environmental justice movement that actually does address pollution in local communities, and
Oh, sure.
and we shouldn't sweep them under the rug. We
No, it's
should be
part of the
applauding
1% I
them
was
and
talking about. If you
fair.
interview the public, do a general survey and said, are you aware that fossil fuels kill 8 million people? Burning of fossil fuels kill 8 million people a year. I'd be shocked if more than 2%, including all the environmental justice people, knew, that was true. It's just, I mean, to me, it's amazing that it's such. It's not like a thing. It's like maybe the biggest cause of death, preventable cause of death there is. Something that we do that causes 8 million, lives to be lost every year. Now, most of them are in China and India, but still 100,000 in the U.S. Still big. I think still more than car crashes and gun shots. But it's just not mentioned. Now we're also able to ignore the gunshot deaths and allow people to have guns and things like that too.
Here,
So
yeah.
we do have the ability to ignore things if we don't like the consequences, or some people don't like the consequences, I should say. Okay.
EcomQuest has been talking about saltwater for marine cloud brightening. Why not just shoot salt into the skies from seawater, not for clouds, but for reflectivity? It's up to 97% reflective and ships pass every moment of every day.
Well, I think the impact of creating clouds are much, much larger. I mean, the salt acts as nuclei for forming a cloud. A cloud lasts for a long time. And you shoot the salt up in the air, it's going to fall back down. It's not going to. I don't believe.
Well, no, the aerosols, if they're small enough, they float around quite happily. And what happens is they eventually take up some water droplets, but until they do that, there is, like the sulfate aerosols, just salt aerosols will do a little bit. The reason that something seemingly innocuous like sodium chloride isn't the first choice for SAI is that the chlorine or the chloride that would interact with ozone. So that's why sulfate is actually better than salt.
But the non-cloud formation portion of the reflectivity is quite small compared to the cloud reflectivity. I'm going to assume.
I've seen it debated in papers, and people have argued both sides. Certainly, in reality, it's going to take up moisture. It's going to become a droplet at some point. So that's the ultimate fate.
Okay. All right. Well, that one may be worth looking into a little bit more then. Let's see.
One aside that Nadia just mentioned, because she must know I love this stuff. It's like, what legal theory distinguishes fossil fuel executives from random prisoners who put poison into things? They know that people will eat or drink without specifically knowing who their victims will be.
Well, I mean, there is a lot of work going on trying to hold fossil fuel companies liable for the deaths that they cause, just like exactly the same thing happened with tobacco companies. And by the way, the fossil fuel companies hired the same exact people, not the same kind of people, the same exact people to help them with their disinformation campaign on fossil fuels. This was quite a while ago. And some of those legal cases, just like tobacco cases, took a really, really long time before any of them were successful. Some of these are moving forward, and there's a chance that they might actually have some impact in the future. So that's a hopeful thing. Okay. More.
Okay. The one, which is, this is like an Elliot inspired question, our predicament: why is no civilization unacceptable? Civilization is what's killing everything. We're the problem,
Well, that's true. By the way, I mean, Elliot, we had Elliot on here. If you haven't seen that program called Discussion with a Doomer, one of our most popular programs ever, by the way.
Yep.
And in it, Elliot expresses he's a doomer. As I put it, he didn't like this at all, but I said, "Oh, you're pro doom." He wants humans to get off the planet as quickly as possible in order to let nature thrive. And by the way, I can't if that's your premise, that what you're going to prioritize nature, and there's nothing wrong with it. I'm not even disagreeing. I'm just saying there are different points of view. And if that is your point of view, that nature over humans should be prioritized, then yes, you're right. We should get off of here as quickly as possible. I think that most people wouldn't do that. I would like to prioritize both. And but again, I'm not saying he's wrong. If it's an opinion, first of all, to prioritize that way. But once you have that opinion and moving forward, that is the natural conclusion to that. But anyway, he's getting his wish the way it's going now. I mean, he wants it to happen quickly so we don't destroy the entire planet and the ecosystems that nature would use to recover. And it is true, the longer we wait, the worse we're going to make it. And it's really, I didn't have time to go into it in the presentation because I'm trying to keep that as short as possible. But the thing that people don't realize about climate change, and again, we've talked about many times here, but really the general public doesn't understand, is that once you do it, it's essentially forever. So whatever, one way to think about it is whatever temperature you hit, when you finally stop emitting, if you're lucky, because the Earth could make it worse, but keep going on that temperature. But assuming that doesn't happen, you're really lucky. Whatever temperature that is, that's the temperature you have for the next 1,000 years, and most of it for the next 10,000 years. So it's not like everything else we're used to, where you have a problem, humans doing some big thing, gun control. Okay, finally we're going to ban guns, whenever that is. Okay, or we're going to stop people from driving cars on their own, or something like that. Eventually, and then when that happens, then things improve and get better. But that's not climate change. When you finally stop emitting, and you don't do SRM, or you don't do carbon dioxide removal, you just only do emissions reduction to zero. When you do that, you're still stuck with whatever temperature and those problems and melting sea ice for a long time. I mean, essentially, the last time CO2 was as high as it is today, 420 parts per million, 425, sea levels were 75 feet higher than they are now. So that means if we stop today, that's where we're headed. I mean, even if the warming didn't continue, there's enough warming now to melt a lot of sea ice and raise sea levels a tremendous amount. So again, it's a different kind of problem. It's not one that you finally say, okay, I'm really unhappy with what's happening. I'm finally decided to go cut our fossil fuel emissions. Renewables are so cheap, it's easy to replace them now. Let's just cut all this fossil fuels finally, and let's get back to where we were. No, you don't get to go back to where you were. I mean, maybe this is
if you're lucky, you stabilize.
But if everyone's like peeing in the pool and finally there's so much it turned yellow and you don't like it, if you get everyone out of the pool, it doesn't change. The water's going to stay yellow, and you're still stuck.
That's a good one.
If you're lucky, you stabilize. But the flip side of what you just said is that if we do SRM, if we do serious carbon drawdown, right, which nobody says wanted to talk about, but if we do those two things, we really can get back to pre-industrial climate. Before we made a mess, we can still stop the cascading, amplifying feedbacks. We can clean up the mess. Nature will heal if we only give it a chance. And by the way, along the way, we can and will be doing the things that do stop us emitting, because we are already at the point where the economics favor renewables, if that's just given the chance to play out.
It reminds me, I wanted to.
Whoop. Stacy, you froze.
Yeah.
So Stacy, I'm going to go. Oh, now you're back. Okay.
There you are.
Okay, yeah, sorry. It reminds me, I wanted when I read through your presentation last night, I was like, oh, some of these should be charts, not Leon charts, but Stacy charts, like, that are easy to see the difference in cost, the difference in emissions, et cetera. Like, this is what we do, and this is what it would be with this, the effect or whatever.
Well, that presentation easily could have been an hour or an hour and a half, but the whole point of it was to try to make it 15 minutes. And when you're doing 15 minutes, it has to just keep going without me. There were so many interesting things in there to get into detail on, like what Mount Pinatubo lowered CO2 in the atmosphere. Like what? People,
Right.
that's another thing people don't realize when they say, no, we have to focus on emissions reduction. SRM is emissions reduction because what happens is you emit CO2, that warms the earth a little bit. That warming of the earth creates new emissions from the earth, which warms the earth a little bit. And that's why when we say climate sensitivity, which we talked a lot about recently here, is 4.5 degrees Celsius for a doubling of CO2. The doubling of CO2 does not cause directly 4.5 degrees. It's, I forget what it is. It's I think a degree or something. Maybe on that order. It's not very much. But what it is, it's the feedbacks, the warming causing warming, that gets you eventually over 1,000 years, by the way, to 4.5 degrees. Over 10 years, it gets you to about 1.5 degrees. And that's the very direct. And so but it works in reverse. So when you cool the earth with SRM, it actually cools the earth, and that cooling of the earth creates less CO2 emitting from the earth. It removes CO2 from the atmosphere, and that keeps going for the next 1,000 years. So you actually end up having sort of this positive feedback effect by doing cooling. And so if you're pro reducing emissions, you should be pro SRM, because it's actually one of the most effective ways. We had a whole show on this about what do you do if you go overshoot. You go over 1.5, or I think this was 2 degrees. You go over 2 degrees, but then you remove CO2 from the atmosphere, and then you come back down and get back down to 2 degrees. They showed if you do SRM, you have to reduce far less emissions from the atmosphere because it prevents emissions from going into the atmosphere. Again, we had a whole show on that. You can go back, look in the archives, and look for that.
One thing. Sorry. Go
just,
ahead, Eli.
Yeah, just a quick point. There is the whole issue of ocean acidification, and that does, independent of temperature, that threatens coral reefs and phytoplankton. And we do have to not just worry about peak temperatures, but worry about how low the ocean pH gets. It is true, as you said, that holding down temperatures reduces how much CO2 is emitted just by the natural responses. But there is what's up there. There is the fact that ocean pH is already kind of at a marginal level where like different crab seasons have to be shortened because they don't grow their shells as quickly, right? And we're on track for things to get worse before they ever get better, assuming we do actually finally do something. So we shouldn't we can oversell SRM because we want everybody to do it, and it does have those benefits that you just cited, but we should also be focusing on how can we do things right. And doing things right means literally cleaning up everything or nearly everything we've emitted to get to pre-industrial levels where nature can flourish, and we can be in a much better situation to support our civilization sustainably by everything we've done between now and then.
Okay. Someone asked, I don't see the question right here, but it was basically, what do we have a cost estimate for what it takes to do SRM? I did mention it in the presentation. An estimate I've heard is about $5 billion a year. Again, what you're doing is you're building 200 airplanes, you're flying them on a pretty consistent basis. just to give you a rough idea, every day, commercial airplanes, there's 100,000 flights. I'm not sure that's just commercial, but there's 100,000 flights every day. 100,000 flights every day. That's a huge, crazy number. So we're talking about a tiny portion of that being these flights to put sulfur in the stratosphere. And it's very straightforward. There's a lot of sulfur around. It's a byproduct of making fossil fuels, and there's literal mountains of it you can see from space, piles of sulfur just sitting there near oil refineries and things like that. So we have a lot of it, and it's cheap, and we know it works because that's the stuff that volcanoes emit. So it can be done, and if it's $10 billion or $20 billion, it's still nothing compared to the cost of climate damage, for example, and to the cost of any other climate solution, such as replacing all fossil fuel infrastructure with green technology, or doing carbon dioxide removal, which literally will cost trillions a year if we did it at full scale.
And
okay.
I do want to mention that, as we've said, sulfate aerosols, that's what volcanoes emit. Those are the best studied, but there are also other natural particles that are emitted by forests, actually, that might be good aerosols. And in addition to those, there are other less studied ones that do not have problems with ozone interaction and might also potentially have other benefits. So the research has just focused on like the best known case, but that's kind of the floor. We can do better.
Mm-hmm. Okay. Anyway, I just wanted to probably cut it off here because we'll keep this to an hour. The interview was only the presentation only 15 minutes, and now we're like at 45 minutes, more than that. But what we're going to do is also edit this program and just publish the presentation only, so that people won't be intimidated by seeing an hour-long program and thinking they have to listen for an hour just to get the most of the information out of there. And I do want to remind people to, to like and subscribe and leave comments on the posted videos, and also share it, and hit the notification bell so you get notified of upcoming stuff. And with that,
can I quickly, there was one issue, the objection that's been raised in our previous discussions that, wealthy nations will do SRM in a way that like everything wealthy nations do, just affects poor nations badly, right? And that could lead to geopolitical conflict. Well, take a look at this geopolitical situation right now. We have conflict, right? It's not like don't do SRM, there's no conflict.
Well, actually, if you don't do SRM, the stress on the world,
that's
on
right,
countries, is going to increase so much that there will definitely be more wars. There may be some wars if we do it, but there'll certainly be more wars if we don't do it. I mean, that's I think pretty clear. And on that happy note, well, let's leave on a happy note. Happy birthday, Stacy.
Thank you.
Thanks for your help over the years here. Thanks, Eli, and thanks to Leon, who's doing a Christmas thing right now in the Netherlands. And thanks to all of you for listening. Again, please help spread the word, because that's why we're here, is to try to inform people about not only the problems of climate change, but the solutions as well. And with that, thanks from Climate Chat, and we will see you.